trigonometric identities up to 4x. You can go beyond 4x, obviously. They're just trying to limit how much they can ask you to do on the external exam. Okay, suppose I ask you for cos 4x. What am I going to do?
Cos 2x.
I haven't even finished my question yet. My goal is usually from one of these to write it in terms of functions of x only, not 4x, 3x, 2x, minus 6x, just in terms of cos x and sin x. So yes, what am I going to do?
Cos 2x.
Oh, 2 times 2x, one option, or 2x plus 2x. Both work. Okay, 2 times 2x. Formula says cos 2 times 2x. I have a choice. There's 3 ways to write that. Since you chose that, Ben, which way am I expanding that?
2 cos squared minus 1.
2 cos squared 2x minus 1. That makes sense, Julia?
It will soon. Just keep going.
How did we get to here? Cos times twice an angle is 2 cos squared the half minus 1. But half of 4x is 2x. Okay, I've still got a problem. Ryan, what am I going to do? This still isn't x.
Do you do it again?
2 something squared minus 1. It's cos 2x. Which one am I going to use, Ryan? Pick one. Same again?
Yeah, one.
Okay. 2 cos squared x minus 1. It's a bit of a mess. Let's try simplifying. 2, 4, sorry, no. Yeah, that's right. 4, this squared, cos to the 4th, x minus 4 cos squared x plus 1 minus 1. You see how all that expanded worked? 8 cos to the 4th x minus 8 cos squared x plus 2 minus 1. Oh. Plus 1. 8 cos the 4th. Yeah, plus 2 minus 1. If I chose different ways to expand the cos 2x here or here, some of the ones involving cos and sine or just sine, I'd get a different expansion. For example,
Why is this useful?
Again, because sometimes you can't use this. Sometimes you only know cos x. How do I evaluate this when I only know cos x? Sometimes if you can work this and go backwards, you might know cos x and sin x. You can work back to this, which is much easier to integrate than this. This is a pain to integrate. Because chain rule is not that simple. Substitution, we'll get to it. It's coming soon, actually, substitution. Let me find you the 4 theta one. For example, show that cos 4x equals cos to the 4th x minus 6 cos squared x sine squared x. I keep losing my line. Plus sine to the fourth x. The question will often be like this: show that this equals something. And you can work from either side. If you want to, you can try turning this into eventually up to that. Or we can go the other way and go, well, we chose ways that only gave us cos. This one has cos and sine in it. So maybe if we use the first expansion of cos 2a, we'll get there. Shall we try it?
Mm-hmm.
Cos 4x equals, I'll do it the same way as I did before, 2 cos squared 2x minus 1. No, I want to go the other way. I want to go cos squared minus sine squared. Cos squared 2x minus sine squared 2x. This one we'll do again, which is, oh, this is squared, right? I'm going to write that.
You're not going to get the same thing.
I'm not, am I? But as soon as I wrote it like that, I thought of another way to do this. That is not what I wanted. This. Okay, your job is to play with that, play with your identities, find a solution. So you can get there before I find one. That might be better. I've forgotten something. Squared. That'll work. That'll work. Which is correct. Did you get that for me?
No. What'd you do?
This to there. What did I do? Place this one, cos squared minus sine squared.
Expanded it.
This one with 2 cos sine.
What'd you do when you rubbed it out then?
Sorry?
What'd you do when you rubbed it out?
I did other ways of expanding. I just kept playing with it until I found one that was going
down
to
here
lead me.
the first time when you zoomed it.
Who did that?
I chose a different way to expand
yeah,
them.
Okay.
But the straightforward expansion works nicely.
So could you be like in the exam trying to simplify it and just be stuck on it for like an hour? Because
No, never, ever, ever.
But what if you went down the wrong path like 5 times?
There's only like 4 or 5 things
Or
to
like
try.
you just ended up on the right one.
It's not going to take you an hour. Did that take me an hour?
Okay, well like more time than necessary, and then like.
So how do you get better at it? How do I get better at it? Practice, practice, practice. Keep
Should
trying.
you just be faster at it?
Just learn and go, this one, yeah. I'm going to write this down here because I want the space up there. For example, if there's a sine squared where you've got a cos squared, replace cos squared with 1 minus sine squared. If there's a cos to the fourth where you need a sine to the fourth, you can be clever like that too. Cos to the fourth x is cos squared x squared, which is 1 minus sine squared x squared. And now I've got sines instead of causes. So you can use those kinds of tricks to switch back and forth. Let me give you another example. Wow, this really went a long way across. Let me do show sine 3 theta. I'll just use theta for fun, why not? Is 3 sine theta. Maybe I can do this without brackets. Let's try. Well, how am I going to break up 3 theta?
2 theta plus 1 theta.
3 theta plus 1.
2 theta plus 1 theta.
I'll hear you better if you don't block your mouth. 2 theta plus theta. Sine of plus is sine cos plus cos sine. Okay, I still need thetas. Replace sine 2 theta with 2 sine theta cos theta. Cos theta. I've got an extra cos here. I want a sine cubed, so let's replace this one with the one that has sine squared in it. 1 minus 2 sine squared theta, sine theta. That'll get me a sine cubed theta.
I did 2 causes in the first one.
Because this expands to that. And I've still got a cos theta.
Yeah.
And this to that. Okay? 2 sine theta cos squared theta plus sine theta minus 2 sine cubed theta. But I need just sine, no causes. So replace this cos squared. 1 minus sine squared theta. Expand the brackets, simplify, see how it looks. Oh, it's going to work. Look at that. Three sine theta minus 4 sine cubed theta works. It's meant to be a T. Or QED, whatever you like.